All right, this video is going to walk you through how to divide and simplify factorable rational expressions. The first thing you're going to want to do as you look at this setup is to first of all look at the expressions. We want to try to factor all four of these expressions. The first expression in the top left corner here is 5x squared minus x minus 4. Now, if you recall how to factor, you take the first term and you put it inside of a box. And then you take the last term and put that in the other diagonal corner of that box. Then you multiply that diagonal and you get, in this case, negative 20x squared. You also take this middle term, this negative x, and you place that at the bottom of the x. Then from there you think to yourself, what two things can you multiply to get negative 20x squared and add to give you negative x? Well, that would be negative 5x and 4x. Then I take those two things that I just came up with and bring them back to the box and put those in the blank spaces that we have. Then from there, you have to ask yourself, what does one row or column have in common? The only thing that this bottom row has in common is an x. So you put an x on the outside. And then in order to get 5x squared, you have to put a 5x in the bottom. Then from here, we're going to then multiply 5x by negative 1 to get negative 5x. And we'll multiply x by 4 to get 4x. And that becomes our dimensions of the box. Well, those dimensions of our box then become the two factors of this expression right here. We'll come back to making this a little bit nicer for this top part here in the top left. Now, some students might also try to use the quadratic formula with this expression as well, where they put in 5 for A, negative 1 for B, and negative 4 for C. When they use the quadratic formula, it will return back to them two numbers. It'll return back to them a 1 and a negative 4/5. The 1 part's not too hard to turn into a factor because that's what the answer would be for the factor that makes it equal 0. Well, in this case, it would have to be x minus 1, the opposite of that number. But when you get a fraction, the bottom part becomes the coefficient in front of the x, and then the top part, you still switch the sign on also, so it'll become 5x plus 4. So if you ever did the quadratic formula on this top expression, you could also get the two factors by simply taking the opposite of the number, and if you get a fraction, you take the opposite of the numerator, and then put the denominator out in front and make it 5x plus 4. All right, now we're going to move on to the denominator of that fraction on the left. We now have 5x squared minus 7x plus 2, and I'm going to go a little bit faster now to make the factoring work for this one here. So we take the first and last terms and put them in the diagonal of the box. We multiply the diagonal to get 10x squared, and then negative 7 gets put in the bottom of the x, as you see here. And then we figure out what two numbers multiply to 10 that add a negative 7. It would be negative 5 and negative 2. Those go over here to the box, and we put those in as well. And then finally, we figure out the dimensions to be x minus 1 and 5x minus 2. And again, if you were to use the quadratic formula with a, b, and c, you would then get 1 for the answer and also 2/5. The 1 becomes an x minus 1. The 2/5 turns into 5x minus 2, the opposite of the positive 2 that you see there. Then we move to the top right, going a little bit faster even so. We're going to turn this 5x squared minus 16x minus 16, use the box, and then put it into the diamond. And we get our dimensions to be x minus 4 and 5x plus 4. Quadratic formula would also give you a 4 and a negative 4/5, again turning that into an x minus 4 and a 5x plus 4. And then we move on to the bottom right. That would factor even faster, and you end up getting dimensions of x minus 4 and x minus 3. Quadratic formula would give you numbers that would come out as 3 and 4, and again, those dimensions, as you see over here, would be the same thing as x minus 3 and x minus 4. Now that I've got all the factors figured out for all four of these expressions in each of the different parts of the fractions, now we're going to have to look at, let's write it out as its simplest form, or not simplest, but in factored form. So now I've got it all written out right here as the factors from each of the dimensions that you see in each of the four different regions here, now listed out in the fraction form. This is a division problem. All division problems can be turned into multiplication problems if you flip the fraction over. The math word for that is reciprocal. We're going to take the reciprocal of this fraction right here, so we're going to move these two factors to the top and those two factors to the bottom, now giving us this expression that you see here on the right. Then from here, we want to look at for common factors that we can cross out. So what I'm looking for next is, are there any expressions on both the top and the bottom of the fractions? So for example, 5x plus 4 can get crossed out with this 5x plus 4 down here. And then I've also got an x minus 1 on the bottom. I can cross out with the x minus 1 on the top. Are there any more? Hopefully your eyes can see it. You have an x minus 4 here and an x minus 4 right here. That crosses out as well. So I've only got two things that I could not cross out that are left. I've got an x minus 3 and a 5x minus 2. So whatever you couldn't cross out then becomes your simplified answer for the final end of this question. So your final answer then becomes x minus 3 over 5x minus 2. And that is it. Hopefully the process of how we got through this helps, and good luck on your questions that involve factoring, dividing, and simplifying. Good luck.